Hello, the topic that I've chosen for my DA1 is file systems. Let's explore the content now. In this introductory video to file systems and concepts, we would be discussing the following topics like what is a file, file attributes, file types, operations, structure, system implementation, directory implementation, file allocation methods, free space management, and also different types of file systems in Windows OS. Let us now understand what is a file. A file is a named collection of related information which is usually stored on secondary storage devices like magnetic disks, magnetic tapes, to name a few. It provides convenient access to the disk by allowing data to be stored, located, and retrieved. From the user's perspective, a file is the smallest allotment of logical secondary storage. That is, data cannot be written to secondary storage unless they are within a file. Also, the information in a file is defined by its creator. There are various types of information that can be stored in a file, some of which are text data, numeric data, photo, music, and the list goes on. Now, coming to file attributes, there are 7 major file attributes. Starting off with name, which is the information kept in human readable form, identifier, which is a unique tag that identifies the file within the file system, type, this information is needed for systems that support different types of files, location, this information is a pointer to a device and to the location of the file on the device, size, which is the size of the file, protection, which talks about the access control, that is what the user can do, reading, writing, executing, and so on, and time, date, and user ID, which can be useful for protection, security, and usage monitoring. Some of the prominent file operations are creating a file, writing a file, reading a file, repositioning within the file, deleting a file, and truncating a file. Now, coming to file types. File type refers to the ability of the operating system to distinguish between different types of files. For example, we have text files, source files, binary files. All these are different file types. A common technique to identify the file type from the file name can be done by, usually in operating systems, the file name is split into two parts. The first part is the name and the second part is an extension. Therefore, this way the user would be easily able to identify the file type from the file name. For example, hello world.cpp. Here the extension is .cpp, which refers to that it is a C++ program. Similarly, image.jpg helps us identify that it is a image form. And similarly, server.c. Various other file types are executable type, which has usual extension like exe, com, bin, or none. Object type, which is obj or o. Source code, batch, markup, word processor like docx, library, print or view, archive, and multimedia. Now let us understand what is a file structure. File systems organize storage on disk drives and can be viewed as a layered design. This layered design is the file structure. Now let us understand the layered structure from the diagram. At the lowest level we find that it's given devices. This level consists of all the physical devices, for example magnetic media. Then coming to input-output controls, this level consists of device drivers. Now device drivers are special software programs which communicate with the devices by reading and writing special codes directly to and from memory addresses corresponding to the card's register. Now it is important to understand that each controller card, that is, device on a system, has unique set of command codes. Then comes the basic file system, which works directly with the device drivers to retrieve and store raw blocks of data, but without any consideration for what is in each block. Now, in contrast to that, file organization module knows about the files and associated logical blocks and how they map to physical blocks on the disk, which is often called as translation. It also maintains the list of free blocks and allocates free blocks to required files. Now then we come to logical file system, which manages metadata information about a file. Metadata information includes all the details about a file except the actual contents. It maintains it via file control block or FCB. And this contains information about the file owner, size, permissions, location of file contents, and so on. Coming to file system implementation. It is nothing but the data structures used to implement file systems. Now let's understand what is internal file system implementation. A block, which is usually called as a physical record, is a sequence of bytes or bits containing some whole number of records having a maximum length. Now disk systems typically have a well-defined block size determined by the size of the sector. So all input-output is performed in units of one block and all blocks are of the same size. Now let us take an example. If each block were of 512 bytes, for example, then a file of 1949 bytes would require 4 blocks to accommodate, which is nothing but 2048 bytes. However, we observe that because disk space is always allocated in blocks, some portion of the last block of each file is generally wasted. Here we find that the number is 99 bytes that would be wasted. So the waste incurred to keep everything in units of blocks instead of bytes is called internal fragmentation. All file systems suffer from internal fragmentation, and it is observed that the larger the block size, the greater the internal fragmentation. The various data structures involved to implement a file system are: first is the on-disk structure. These structures contain information regarding total number of disk blocks, free disk blocks, their location, and so on. The various types of on-disk structures are boot control block. This is also known as boot block in Unix, UFS. Here UFS stands for Unix file system, or the partition boot sector in Windows, NTFS. Here NTFS stands for New Technology File System, which is a process that the Windows NT operating system uses for storing, organizing, and finding files on a hard disk efficiently. Now boot control block contains information needed to boot an operating system from that volume. Then volume control block. This is also known as the master file table in Unix, UFS, or the super block in Windows. It contains information such as number of blocks on each file system, pointers to free blocks, free FCB blocks, and partition table. Then directory structure. It is used to organize the files. In Unix it uses inode numbers, and in Windows it uses a master file table. Then per file FCB. This contains information about the size, permissions, ownership, and date. In UFS it stores these details in inodes, and in Windows in the form of a relational database structure. Now coming to the second data structure used. These are called in-memory structures. These structures are maintained in main memory and are helpful for file system management as well as performance improvement via caching. Now cache memory is used to reduce the average time to access data from the main memory. The cache is a smaller and faster memory which stores copies of the data from frequently used main memory locations. Different types of these structures are given as: first is mount table. Now first let's understand what we mean by the word mount. Mounting is a process by which the operating system makes files and directories on a storage device available for users to access via computer's file system. So in a mount table, it records the file systems that are actually active, that is, contains information about each mounted volume. Then the second is directory structure cache. This cache holds the directory information of recently accessed directories. Coming to the third one, system-wide open file table. It contains the copy of file control block of each currently open file as well as some related details. Then the fourth is per process open file table. It contains pointer to the system open file table as well as some other information. Now let's come to directory implementation. Directories should be fast to search, insert, and delete with a minimum amount of wasted disk space. Let us see how we do that. Before diving into the implementation aspect, Let us understand what is a directory. The directory can be viewed as a symbol table that translates file names into the directory entries. Now, directory itself can be organized in many ways, some of which are: the first one is single level directory, which is represented by this diagram. Then we have two level directory, which is represented by this diagram. Then we have tree structured directories, which look like a tree, which is represented by this diagram. And then we have acyclic graph directories, which is represented by this diagram. And the general graph directories is a combination of mix and match of all these four types. So the organization must allow us to insert entries, to delete entries, to search for a named entry, and to list all the entries in the directory. Two prominent ways of directory implementation are: the first one being linear list. A linear list is the easiest directory to set up, and it requires a linear search for finding a file. In order to delete a file, we search for the directory for the file name and then release the space. Also, sorting the list makes searches faster, however, at the expense of more complex insertions and deletions. And to reuse the directory entry, either we can mark the entry as unused or can attach it to a list of free directories. The disadvantage of this implementation technique is it is time consuming. The second is hash table. In a hash table, the data is stored in an array format where each data value has its unique index value. The access of data becomes really fast if the index is known. A hash table can also be used to speed up searches, that is, it decreases the search time, addresses the disadvantage of linear list. Hash tables are generally used in addition to a linear or other structure. The only disadvantage of hash table is the major difficulty is hash tables are generally fixed sized, and hash tables are dependent on hash function on that size. So that is a major disadvantage. File allocation methods. Here, allocation refers to the method of how disk blocks are allocated for files. There are three major file allocation techniques, namely contiguous, linked, and indexed. Coming to the first allocation technique, contiguous allocation. In this method, a set of blocks is allocated to a file at the time of file creation itself. So coming to the diagram, if we see, the file count starts from 0 index and has a length of 2. So we see 0 and 1 are initialized during the time of file creation itself. So this way it can be called as a pre-allocation strategy using variable size portions. Multiple blocks can be read in at a time, so this improves the performance for sequential processing. Also, it is easy to retrieve a single block. The disadvantages of this allocation technique is the first one being overestimation of the file's final size increases external fragmentation. Secondly, underestimation may require a process to get aborted if the file grows beyond its originally allocated space. Also, if a file grows slowly over a long time period and the total final space must be allocated initially, then there is always a chance of lot of space becoming unusable before the file fills the space. In contrast to the first allocation technique, linked allocation is a non-contiguous allocation technique. So in this method, allocation is done on an individual block basis. Let us see from the example. The diagram that is given here, in that the file Jeep starts from the 9th block and ends to the 25th block in a linked list manner. So first from the 9th block it goes to the 16th block, then goes to the first block, then comes to the 10th block and finally reaches the 25th block. So disk files can be stored as linked lists with the expense of the storage space consumed by each link. Linked allocation involves no external fragmentation, which is a plus point, and allows files to grow dynamically at any time. The disadvantage of this process is there is an overhead to maintain the pointer in every disk block. So, if the pointer of any disk block is lost, the file will be truncated. Also, it supports only the sequential access of files. Coming to the third allocation technique, which is indexed allocation. In this method, we find that the file allocation table contains a separate one-level index for each file. So the index has one entry for each block allocated to the file. Also, allocation can be done on the basis of fixed size or variable sized. Now, fixed sized eliminates external fragmentation, whereas allocation by variable sized blocks improves locality. So this allocation technique supports both sequential and direct access to the file, and thus is the most popular form of file allocation. Free space management. This is also a very important type of management which helps to keep track of space and allocating free space. To perform any of the file allocation techniques, it is necessary to know what blocks on the disk are available, that is, the free blocks. So we need a disk allocation table in addition to a file allocation table. The various approaches adopted are the first one being bit vector. In this approach we find that each bit represents a disk block such that it is set to 1 if it's free and 0 if allocated. Now this has the advantage that it is relatively easy to find one or a contiguous group of free blocks, so it works well with any of the file allocation methods. Second is linked list. A linked list can also be used to keep a track of all the free blocks. So generally the system just adds and removes single blocks from the beginning of the list. So the file allocation table keeps track of the free list as just one more linked list on the table. So no space is wasted in this manner. Then we can talk about the free block list, in which each block is assigned a number sequentially, and the list of the numbers of all the free blocks are maintained in a reserved block of disk. So in the diagram we see that the lowest level block is the disk block where the numbers are stored. Some other famous free space management techniques are grouping, counting, and space maps. Just to understand how the file systems have evolved over time, we'll explore different types of file systems in the Windows OS. The first one is FAT16. The advantages of this are it can be used in very old OS like MS-DOS, Windows 95, 98, NT and 2000. But the limitations are it can only support partition which is smaller than 2 GB and it causes a waste of space. Then we come to FAT32. This supports partition of 2 TB and most of Windows OS, Mac and other OS and devices. FAT32 has lower faulty tolerance security compared with NTFS. Then we come to NTFS. Now this provides faster speed and allows large space. It also has better security to resist data loss. However, it doesn't support OS older than Windows XP and can be only read in Mac and some other OS. Then we come to exFAT. It has better compatibility than NTFS. It can be used in Mac and Linux OS as well with full write and read. exFAT has extra features that NTFS provide. So we see how the basic file system has evolved over time. This list is the list of references that I've used to make this PPT. Thank you.